All right, hello everyone. This lecture is going to cover derived unit conversions. As it says in the notes, derived units are units that are calculated made from combinations of called base units. So some examples I've given you here: area, like meters squared, or feet squared. Like, you know, you take an area and then multiply, like, you know, base times height or whatever, length times width, however you want to look at it. And then that was how you would get those units. Volume, because volume is a cube, it includes height. So if you're looking at like volume, if you think about a cube, right? And okay, you think about a cube. Well, to do the volume of this, you would do length times width times height, right? Well, that's where you get the cube from. You would do the distances times itself 3 times, and you get the cube. Okay. Some other ones: density. Density is mass over volume. So your label ends up being a mass label over a volume label. Okay, speed is distance over time, right? So that's another one. Okay. These are what are called derived units. And by the way, like, I wrote the speed label like this: miles per hour, mph, is the same thing. mph is miles per hour as like a ratio. That actually means this, okay? Another one, actually, if you guys ever have heard, like, if you shoot guns or paintball guns or anything like that, they've got what's FPS. It's feet per second. Again, that's a speed. So feet per second is the label. Okay. All right, so those are derived units. You treat units the same way you treat variables in algebra. They can be multiplied, divided, etc. A conversion is an equivalent ratio, that means the top and the bottom are equal amounts, of one measurement amount to another. The following are examples of conversions with derived units. Okay, so the first one, I'm gonna try to slide this up a little bit here. So again, you'll need your conversion factor help sheet. Okay, so the first one is convert 75 miles per hour to meters per second. So the first thing that's important to do correctly on this is the setup. We're still going to use the dimensional analysis. So I do 75 and miles, 75 miles per hour, or miles / hours. It's like a ratio like this. The hours is on the bottom. Now, if you want to put 1 here, like, think about, what does 75 miles per hour mean? Well, it means you go 75 miles in 1 hour, right? So if you want to put a 1 down here, that's fine. You can do that, just to kind of be a placeholder, but you don't have to. But it's got to be, the miles is on the top, the hours is on the bottom. All right, now we're doing a dimensional analysis, factor label. Now here's the trick to this. The trick is we're changing miles per hour to meters per second, but we're not going to do it all at the same time. Okay, we are going to focus on one of the two. It doesn't matter which one you do first, but you're either going to change miles into meters, or you're going to change hours into seconds first, and then we'll go back and focus on the other one. So, sorry, it's getting blurry. There we go. Okay, so I'm going to do miles first. I'm just going to ignore my hours here for a second, okay? So I'm just pretending this isn't here. I'm going to do miles. So I want to get miles into meters. So this I go through and I do the same way that we were doing the other conversions. I look up miles. I don't have a miles to meters. I do have a miles to kilometers though. And I know from what we did yesterday that I can go from kilometers to meters because they have the same root. That's metric to metric. So I'm going to do that. So I'm going to do, so my miles is on the top. So miles comes on the bottom so we can cancel. I'm going to turn into kilometers. Okay, I do, my conversion tells me it's 1 kilometer for every 0.62137 miles. Okay, now if I look at this, right, my miles cancel. So what I have now is I've got kilometers over hours technically. So I've got kilometers. Now I want it in meters, so I'm going to do another step. Kilometers on the top, kilometers goes on the bottom. Turn to meters. Okay, this is a metric to metric. So I go to my back of my conversion, this, right? So remember, a 1 always goes in front of the thing with the prefix. So a 1 goes in front of this. Okay, and kilo, 10 to the third, that goes in front of the thing that's just the root with no prefix. Okay, I get here. My labels cancel, right? All right, now at this point, let's look and see what we have. What are my labels currently right now? It's meters over hours. I want meters over seconds. So I'm done with, I've got the top part to be what I want. I'm done messing around with this. Now I just need to focus on the bottom, the hours. The nice thing is we don't have to like do the math and then go back. We can just keep going. You know how we just ignored the hours and just left it there? Well, we're gonna do the same thing with the meters for now. Okay, and we're gonna do another conversion. We're just gonna ignore the meters. We're gonna go back here and look at this. I need to change hours into seconds. Okay, now I don't have hours to seconds, but I do have hours to minutes. So I'm gonna do hour on the top. Now here's where you have to watch. Remember, we wanna cancel them, right? So 1 has to be on the top, 1 has to be on the bottom. So since hours is already on the bottom here, I have to put hours on the top diagonally so I can cancel them. So I'm gonna go from hours and I wanna turn that into minutes. So minutes is gonna be there. Okay, so I know it's 1 hour for 60 minutes. Okay, now cancel labels. Hour cancels, top and bottom. Okay, now I'm in meters per minute. I want to be per second, so I'm going to do another one. Minutes is on the bottom, so minutes has to come on the top because that's what I'm trying to cancel, get rid of. Turning that into seconds. I know that it's 1 minute for 60 seconds. Okay, at this point, my minutes cancel. Now, look at the label we have left. What's left on the top? Meters. What's left on the bottom? Seconds. It's exactly what we want, meters over seconds. Okay, now we can just do all the math. Okay. Now, here's something else that I didn't really mention the previous days, and hopefully you guys figured it out, but just in case. When you're typing this in your calculator, you are gonna multiply by anything that's on the top and divide by anything that's on the bottom, okay? So, I think the easiest way, and I just ignore ones, right? To me, the easiest way to do this, let me see if I can get this on together on the screen here. Okay, is I just go kind of in order. So like I start with 75, okay, ignore the one. This is divided by 0.62137. Okay, this is times, because this is on the top, 10 to the third. Okay, don't have to worry about the one there. Okay, the one there, the 60 is on the bottom, so divided by 60, and here's where people sometimes mess up. The 60 is on the bottom, right? So you gotta hit divided by 60 again. I hit divided by before everything that is on the bottom, okay? I get this, okay, 33.528, blah, blah, blah. And if I look here, my significant figures are 2, so my answer needs 2. So the first 2, 3 and the 3, the 5 does round that up. So I get 34 meters per second is my answer. Okay. So that's how you type it in. Now, there is another way you can do it, because what some people try to do is they think it's like, oh, 60 times 60 on the bottom. You can do that, but what you need to do is put parentheses. Like, in other words, if you want to multiply the top and then divide by everything on the bottom, you could do it like this: 75 times 10 to the third, okay? That's everything on the top, and then do divided by. Now, if you do everything on the bottom and you multiply these, what you should do on your calculator is do divided by, then put parenthesis 0.62137 times 60 end parenthesis. And that'll give you the right answer. If you don't put the parentheses, it'll give you a messed up answer, because what your calculator will think you're doing then is it'll think you're doing this times this divided by this and then times these again, like those are on the top, but they're not, they're on the bottom. Okay, so be careful of that. All right, next one. Similar deal. Convert 567.4 milligrams per centimeter cubed. I forgot to put what we're converting this to. We're going to convert this. I'll make sure I fix it before I upload the notes to you. We are going to convert this to ounces per gallon. All right, so very similar to the speed one up here, we're going to start with this. Milligrams per centimeter cubed. Again, you can put a 1 down there if you want. You don't have to. All right. So this one's going to be a little longer. Actually, I better watch how big I make my steps here. So I need to get milligrams into ounces and centimeters cubed into gallons. So I'm going to look milligrams to ounces. Okay, so this is a mass, right? I don't have milligrams anywhere on here. I have ounces here. The only thing I can turn ounces in is pounds. So what can I turn into pounds? Well, I can do kilograms or grams into pounds. Grams, I could turn milligrams into grams and then do grams to pounds, pound to ounces. So that's what I'm going to do. So I'm going to do milligram on the top, so milligram on the bottom. I'm going to turn that into grams. This is same root, right? So this is metric to metric. A 1 goes in front of the label with the prefix. To find what goes in front of the root, I look up milli. Milli is 10 to the negative third. So that goes in front of the root with no prefix. Like this. Okay. Labels cancel. We end up with grams. Now we're going to do another one because you need to get into ounces. So we're going to go grams to pounds is the first one we have to do, right? Using this, right? So grams on the bottom, pounds on the top. It's 1 pound for 453.59 grams, like this. Okay, so now grams are canceled. We got pounds, and now we can go pounds to ounces. Again, from this, 1 pound for 16 ounces. Right? Pounds cancel. All right, we finally got our top into the unit we want, ounces. Now we can leave that and we're going to focus on the bottom, centimeters cubed. We need to get centimeters cubed into gallons. If you see any kind of length measurement that is cubed, that's going to be a volume, okay? So we've got centimeters cubed and we want to get it to gallons. So if we look here, okay, we've got a couple of centimeters cubed. What do we have for gallons? We've got quarts and we've got liters. Okay, the only thing we get liters to quarts. So it doesn't make sense to go into quarts to like liters to quarts and then quarts to gallons. It just makes sense to go right from liters to gallons, right? So we need to get centimeters cubed into liters. We don't have that, but we do have this, centimeters cubed to milliliters, and we know milliliters can go into liters. So that's what we're going to do. So we're going to do Centimeters cubed is on the bottom, so it comes on the top. Turning that into milliliters. And our conversion for that, actually, if we look, that's a 1-to-1 ratio. 1 milliliter is equal to 1 centimeter cubed, so they're just ones. Now you should still put the step in because it's going to help you make sure you're doing the units correctly. Okay. All right, now we can go milliliters to liters. 1 always goes in front of this is a metric to metric, right? 1 goes in front of the label with the prefix. Milli, we already did it over here. Milli we looked up was 10 to the negative third. It goes in front of the root. Okay, we're going to cancel some more labels. Okay, now we want to go from liters, and we need to get into gallons, right? And we look, we've got liters to gallons. So that's what we're going to do. So one more step here. Liters on the top, gallons on the bottom. And our conversion on our sheet says 1 gallon for 3.785 liters. Like that. Cancel our labels again. Liters cancels, we got gallons. Now, if we look, what are we left with our labels? On the top, we're left just with ounces. On the bottom, gallons. That's exactly what we want. Ounces over gallons. Okay, so now that we've got our labels, we can actually do the math. So we're gonna do, let's see, type this in. Do 567.4 times 10 to the negative third divided by 453.59 times 16 divided by 10 to the negative third times 3.785. And we get this, which is going to, okay, so significant figures, we've got 4. So we need 4, so it's 7575, so it's 7575, and then this 5 rounds that 5 up. So we're gonna get 75.76 for significant figures, and our label is now ounces per gallon. That's our answer. Okay. All right. Hopefully these are making sense. Now our third one is a little different. I put it in the form of a word question, and it's going to deal with the units a little differently. So this is actually something that it would be like real life. Like we measure houses in square foot and square feet. So we've got a house has a listed square footage of 2,450 square feet. What is this in square meters, meters squared? Okay, so just like everything else with dimensional analysis, we're going to start with our number they're given. So 2,450 square feet, right? All right. Now, we don't have area conversions on here. Okay, there's no area conversions. So we don't have a feet squared on here anywhere. Right? The only thing we do have, we've got feet here. We got meters. We can't turn feet right into meters. We don't have that. We have feet to yards, and we could turn yards into meters, right? Okay, so if I do, so a step here, I do feet's on the top, so feet on the bottom, to yards, right? So this is it's 1 yard for 3 feet. Okay, that's our conversion off of this, right? Now, if we look at this is only counting, like, it's only one foot label and yard label. All right, feet here, this feet squared is technically like a label of feet times feet, right? Times itself, that's what squared is. So if we had to put foot down here, like this, we only technically cancel one of these. All right. So what do we have to do? Well, we technically have to do it again. 1 yard, 3 feet, like this. Now look what happens. We've got feet times feet on the bottom, feet times feet on the top. So these can cancel. Okay, now what do we have on the top? Well, we've got yards twice. So what is that? Well, that's square yards, right? So if we wanted in square meters, what do? Well, another step. Yards on the top. So we've got yards on the bottom. We're turning it into meters. We're going to use our conversion from here. Where is it? 1 meter is, oh, I gotta squeeze this in here. 1.0936, sorry about that, yards. Okay. Now that cancels one of the yards, right? Well, we got another one. So we're gonna do it again. 1.0936 yards for 1 meter. Yards cancel. Okay, now what's our label? Meters times meters. That's meters squared. That's what we want. So we can do the math. So we do 2,450 divided by 3 divided by 3 divided by 1.0936 divided by 1.0936. Enter. We get this, significant figures here, no decimal, so we count from the right. We don't start with the 0, we start with the 5. There's 3. So we need 3. So it's the 2, 2, and the 7. The 6 does round the 7 up. So we get 228 square meters. That's our answer. Okay, like that. Now, when you're setting these up, there is a way that you can, if you're doing any kind of like area or anything like that, or volume ones, excuse me, that you can do this a little more simply. Let me show you. So an alternative, let me do this in a different color. Let's see. So start with, again, with the 2,450, right? Square feet. We're going to do 1 yard, 3 feet. Now, what is the effect of doing this twice? What is that really doing? Well, that's really taking it times itself, right? So it's just squaring it. So you square like that. Now, the only thing you have to be careful of and remember when you're doing this is you've got to remember that when you type this in, that's 3 squared. I'll show you. So we're going to do the same thing here. 1 meter over 1.0936 yards. And we're going to square that entire thing because we want that squared to get rid of that, right? Okay, when you type this in your calculator, you are going to so 2,450, right? Now this squared is only on the feet here. So that's already been squared. Now here, these have not. So we're going to do divided by 3 squared, because we're squaring that on the bottom, okay? If there's something on the top, we do times whatever it is squared. Okay, we're going to divide it by, again, 1.0936 squared, and boom. See, it gives us the same answer. just like that. All right. Okay. One last little thing is, if you look on this and you see, like, for example, see the inches cubed equals 1 inch cubed equals 16.4 centimeters cubed. Those have already been cubed. Okay. And I can show you this. See how it's 1 inch is 2.54 centimeters. So watch what happens when I do, if I take this and I do 1 inch, okay, and one cubic inch, and I turn that into cubic centimeters. If I use the one from up here, okay, if I do 1 inch and 2.54 centimeters, like this, and then I cube the whole thing, watch what happens. So I do 1 times 2.54 cubed, 16.4. Okay, so these conversions, if they've already got a cubed or a squared or whatever on it, they've already been multiplied out. You don't have to do it again. All right. Okay, hopefully that helps. I know it's a little longer, but I just really want to make sure that stuff's clear. Let me know if you guys have any questions, and good luck.